Dan Abbott. I'm making this video from my CAD Graphics class at Southern Maine Community College. This is the presentation that I didn't give during the week of Thanksgiving because we didn't have class, and I told you I would make a video showing you how to approach the next assignment so that if you wanted to get started on it now you could. So I'm looking at assignments here. This is an offset section assignment. Sections, as we've done already now, 2 other section drawings. This means something where you take an assembly and you cut it. This is going to be an offset section, so you cut it through the components that are most important that you want to demonstrate or illustrate in a full section assembly. One of the documents is the assembly PDF document. It looks like this. These are all the individual components, so you know what the dimensions are that go into this assembly. It's a caster. It's a wheel that gets bolted to the bottom of a steel bin. You're not drawing each of these individual parts by themselves. What you're doing instead is drawing the assembly as it's put together and showing what it would look like if you were to make a cut down through it. And I'll demonstrate that a little more thoroughly in a minute. One of the things you won't do is put any of these dimensions on the full section assembly. Full section assembly should look like this. So what you want to do is to duplicate this sheet right here. So in other words, you're going to show what this part would look like, or what this assembly would look like if it were cut in such a way that it exposed the fasteners, the shaft, and each of the components by doing a cut that goes down through the center. So you're looking at the cross section of the wheel, the cross section of an axle support, the cross section of a bushing, and all of those dimensions are shown on the other PDF file. Now if you want to just visualize what I'm talking about, this is the assembly put together in SolidWorks. Now this is not what it would look like in the drawing, but this is the idea conceptually that you're going to cut offset through the assembly. So you're starting a cut that goes right through the fastener, offsets over to the center of the entire assembly, offsets back, goes through a fastener. So the individual components, you're going to show that surface, you're going to show that surface right there, that surface right there. You're not going to include those edges because they don't really exist, so it's just what the edges would be if you were able to cut this. The other thing you're not going to do is you're not actually going to show the bolt, the washer, or the nut as though they were cut, and you're not going to show the axle as though it's cut, because by convention in a full section assembly drawing, those items are not sectioned. They're drawn as though you can look at them from the outside, because it makes the whole thing clearer and easier to read. So you look up here, that obviously looks like a hex-headed nut. Down here, a hex-headed bolt. Hex-headed bolt coming down through with a hex-head nut in the washer. None of those are cut through. The axle itself, also not cut through. The other components are all shown as though they were cut. You don't see those edges where that offset would take place because that's not really part of the assembly or part of the component. And then you use various hatch patterns and symbols to differentiate the individual components. A couple of things about this is you want the angle to vary. The material itself is identified by the type of section you use. So this section symbol right there is steel. Most of this is iron, cast iron, so you just have lines that are separated by about 3 millimeters or about 1/8 of an inch. Down here you have these bushings that are made out of bronze. Bronze as a material has copper in it. Copper-based materials have a different section symbol. So instead of just being these parallel lines that are 1/8 of an inch apart, every other line is a hidden line type to represent a different material. Here, every third line is omitted to represent that that's steel. When you have components that are mirror images of each other, you don't give them the same section angle because they're not the same part. Anything that's the same part has the same angle. So the wheel is a good example of that. If you look here, the top part of the wheel, the bottom part of the wheel, this is all one part. So the section lines are at the same angle, they're the same section symbol, and they're the same spacing. Up here you have the same thing where this top plate extends out past the bolt hole. So that line right there, it's the same angle as this line right here. The spacing is the same as the spacing. Now when you look at the axle support, the same thing by the way with the bushing above and below, the axle support above and below. Look at the axle support. There's another identical axle support on the other side, but it's the mirror image. even though they're the identical parts, they are not the same part. There are two of them, not one. So this cut surface would have an angle that was the mirror angle, mirror image angle of whatever's on the other side. So whatever you put here, you just mirror that hatch pattern over here by adding 90 degrees to it. Same thing down here. You don't want two parts that touch to have the same angle, and you don't want two separate parts to have the same angle, which is why up here you have a shallower angle. Down here you have actually another shallower angle. So the angle here and the angle here are not the same angle. Angle here and the angle here are not the same angle. The difference between the angles has to be at least 15 degrees in order for you to visually get a sense of what it looks like. So your job is to, in AutoCAD, this drawing was done in SolidWorks, but your job is in AutoCAD to duplicate what you have here. There's a detail up here. You're going to do that with a separate viewport. You've got the full section assembly here. You're going to show that as though the cut were at an offsetted, the cutting plane was offset, so that you're cutting through the bolts, but then moving the cut plane up to the center of the part to show what it would look like if you cut through the center. That's just the right side view. You don't normally put a top view here, although you might want to draw a top view just to give yourself something to project down for the size of the holes, but you don't have to. You're going to use a title block of some kind, complete the title block. That's a revision table. Revision table simply lists any revisions that are made to a part. Up here you have a bill of materials, often called a BOM, which is just the initials of bill of materials. And this is a listing of all the individual parts. Those numbers here correspond to the numbers over here in what are called balloons, for obvious reasons. The balloons identify each of the individual components. And the only other thing on here to point out is, if you're pointing to the surface of something in a mechanical drawing, you use a dot as an arrowhead. If you're pointing to the edge, you use an arrowhead with a point. So that point touches that bushing. So number 4 is the bushing. If you take a look at number 8, number 8 sitting on top of a surface, that's why you have a dot there. Number 8 is going to be the bolt. So you look over here, caster bolt, and Rev 00 is just a revision number on those parts. Then you have a description, and you have a quantity over here for the bill of materials. Scale bar is not necessary. I do that if it's a part a drawing I'm going to hand out, because when I print it, I might print it smaller. So just so you understand that it might not be printed at the same scale that the drawing was done. This part was drawn on B-size paper at a 1:1 scale. But if I printed it out on A-size paper, I'd shrink it down. And what I shrink it down to would be to fit, probably, so I could pass it out to you. But that's just so you can tell what the actual scales are if you wanted to measure, to estimate some of the distances. The only dimensions are the overall, they're called catalog dimensions, the overall size of the entire assembly. There are no individual dimensions for each part here. Those would go in part drawings, which would be another sheet in this set. At least one more sheet, maybe more. So the overall width of the caster, the overall depth of the caster, and then the overall height of the caster and the size of the wheel, those would be the only dimensions you would need on this or want to put on. So when you draw this in AutoCAD, you really have a couple of possibilities. In the first place, I'm going to give you a block that consists of that bolt, the washer, and the nut, so that you don't have to draw that. I can show you how to draw a nut like that. That's the standard symbol for a hex-headed fastener. And the standard symbol is an arc, a larger arc, an arc. There's a little chamfer on the edge. That chamfer is 30 degrees on an actual bolt. I always draw it 45 so it opens up a little better. Got a little space here. There's actually a tiny little bit of space here as well. Anyway, anytime you see that, you're looking at a symbol representing something that has a hex head, whether it's a nut or a bolt. The hidden lines represent the thread. That's what's called a simplified thread representation. In this case, the thread only goes up as far as that, and the rest of that bolt is unthreaded. So you have a couple of approaches. One, I would take the fasteners themselves, I would draw as an individual block. You could also draw the axle as an individual block. Now the rest of this, you can either draw as lines, put the blocks in place, and then trim them back to the blocks. Or you could draw them where you've got a block that consists of the opening into what you're going to place that bolt. Either one of those would be perfectly reasonable. the nice thing about creating blocks out of these shapes, if you can make a block for the top plate, it would be this section, and this section all together. Now you can just insert it, and it's a lot easier to manipulate. Or you can draw the individual lines. Either way, recognize that this is symmetrical through a vertical center plane or line of symmetry. Everything on the left side is exactly the same as everything on the right side. You always draw an assembly where the parts themselves are centered. That's just the convention. Even though it's free in this case, the wheel's free to move back and forth, and the axle's free to move back and forth a little bit. So I will open up the drawing file. I'm going to give you a drawing file to start off with. So let's go back and take a look at that. So here's your drawing file. Download that. I'm going to open it up. So I have a bolt here for you, and that bolt is something that you can use as a block if you insert it into another drawing. It's drawn a little differently than the SolidWorks one. When you're drawing individual lines as opposed to drawing in SolidWorks, normally you just indicate that the threads stop here and that the thread itself is shown as the hidden lines. So you want to bring this into your drawing so you have a bolt that you can use. I'm going to start by just saving this, and I'll just put it, I'm just going to put it in my downloads folder, which is actually where it is already, so I'm all set to do that. Now I'm going to start a new file. The new file I'm going to start has got to be based on the ACAD ISO template because it's a metric drawing. So we start this, and rather than do a setup of the layout, I'm just going to go ahead and start drawing these parts. Now to draw these parts, you're going to need to know what the dimensions are. So I've got this open. Again, this is what it's going to look like when we're done. But the dimensions for each one of these things, I'm going to get those from, back here. I'm going to get those from this drawing. So I'm just going to start with that top plate, since that's what holds everything together. If we take a look at the dimensions, it's overall 136 millimeters. It's got a drop up here of 4 millimeters. The overall thickness is 16. And then we don't need to worry about the depth on this until we do the side view. So all I want to do is draw this from one point of view where we see that little cutout, and then we see that little protrusion that comes down. And I'm going to go ahead and draw the hidden lines in there as well, representing the holes. Maybe what I'll do is start by drawing a top view of it just off the sheet. It's going to end up being off the sheet, just so we can have something to project down and you can get a better sense of what it looks like. So I'm going to put this aside, and I'm just going to, when you watch this video, it's a good idea to have that open while I'm doing it. So I'm going to go over here. I'm just going to start anywhere, and I'm going to draw a rectangle. I'll draw the rectangle representing the top view of that top plate, and that's going to be at 136 millimeters by 82 millimeters. So it'll look like that. And I'm going to go ahead and put the fillets in there. Fillets have a radius of 12. I'm going to go and just make the fillets here. I could actually have done this at the time I made the rectangle. There's an option for putting fillets in every corner of a rectangle that you create, but I didn't think of it, so I didn't do it. Okay, now I'm going to have a dimension that goes here, a hole that goes here, and the size of that hole has a diameter of 11. Goes like that. I'm going to mirror the last thing that I created right around the midplane of this. Does that. Now I'm going to mirror those holes right here. Now again, this is not part of the assembly. This is just so that I can have something to project down. So now I have something to project down. So now what I'm going to do is say, let's do the front view. I'm going to start right here. I'm going to go over 44 millimeters. I'm going to go straight down 4 millimeters. Go back over here. Now I'm going to do a little bit of, see, I'm going to just draw a line that goes all the way down through here. And that line is just a symmetry line. And what that allows me to do then is to draw one side of this and then mirror it to the other side, so I don't have to worry about doing any math on this at all. So it is 12 down to here. Comes over this way. Oh, but 60. Just doing a little bit of math here. 38. Coming down from there, I come down another 4 millimeters. Come back over to here. So now I've got a couple things I could do here, but I'm just going to mirror this for now. I'm going to mirror just those lines right there. I'm going to mirror them over here like that. And I'm doing just those lines because now I want to just extend these instead of having two lines that are end to end, because it's just not a good idea in AutoCAD to have two lines that go end to end when what you really need is one line, because it looks like one line. So now I'm going to go ahead and project this down here. That's the hole. These would be hidden lines in this view if I weren't doing a section. And again, don't forget you got symmetry. So once I've done one of those, I'll just bring it over here, bring it over the other one, press enter. Now that's the entire front part of this. This is, you know, what it looks like in its entirety. If we go back and look here at this, which I have off to the side, the actual assembly, that's all I need for that top plate right there. Now I'm going to go ahead and I'm going to draw the axle support, but the top plate is done. Now I could just keep going, and when I come and bring my bolt in, by the way, when I do bring that bolt in, let me just go do that right now. I'm going to insert that from a library, and the library I'm going to insert it from is going to be, in this case, it's going to be in my downloads folder, because that's where I place that file. And it is right there. So now when I bring that in, once it finds it, I bring that in, that bolt right there is going to be sitting on top of a steel plate. I haven't drawn the steel plate yet. The steel plate's a phantom line because it's not part of the assembly. But I do know that that steel plate is going to be a single line that goes here, goes over through here. I'm going to offset that 6, which is the thickness of the plate. Bring that up here like that. I'm going to extend those lines up through. Now we'll do a trim. Get rid of that and get rid of this. Get rid of this and get rid of that, because this is how it's going to look in the assembly. Now I also have a little bit of a short break line over here. You notice I'm not putting anything on layers yet. I'll just do that after I'm all done. I'll just move things to the right layer. So if I do that and then I p-edit this, that was a poly line. I p-edit it, make it into a spline. That looks pretty good to me. Now what I'm going to do is to mirror that so it comes over to the other side. And that was not what I wanted. Let me do that once again. I'm going to mirror that edge. I didn't go straight down, and this was the problem. So now I've got my little short break line here. I can extend this line so it hits this and hits this. And I'll come in and do the hatch pattern on that a little bit later. But that now would be my top plate. So if I were to move this bolt into place, this bolt would be going right here, midway between 2 points. So it would go halfway between this point and this point. And that's what it would look like. We've got some space around it because the hole is larger than the bolt. That would also be mirrored. Mirror line would be right here. So now that's fitting in place. So I'm just sort of putting this together. Now again, you can leave this way, or you can make a block out of these things. I'm just going to leave it. That's the only real block that I need. I might make a block out of the make a block out of the shaft, because that's something that sits on the outside as well. So for now though, before I can go any further, what I need to do is to draw the axle supports. So the axle support, the axle support is given, the dimensions are given in two places, one over here and then one over here. There's no actual dimensions given over here, but it does show you what you have, and that little raised boss sticks out. So when you draw this, you're going to end up with something that's essentially L-shaped, but it's going to have a raised boss down here where the part gets thicker by 2 millimeters, and then it's going to have a hole through it, so that when you set it up in the assembly itself, it's going to look like that, kind of an L-shaped piece. Going to come out with a raised boss. The dimension of the boss is given as a diameter. The thickness of the part here is 10. The thickness of the part here is 12. It's 10 up here as well. You've got a little arc here. And again, I'm just going to draw it. And I'm going to go ahead and draw it in place with the bolt, because then I can use the bolt to do my trimming for me. And you'll notice there is a pocket. That's called a spot face right here. And the washer fits up inside that spot face. So the lines for the spot face are going to be drawn as though they were object lines, and then I'm going to trim them so they don't go right through the bolt itself. And by the way, there are all kinds of ways that you can approach this. I'm not suggesting that you need to follow what I'm doing and do it exactly like this. In fact, I prefer that you didn't. I'm just giving you a sense of how you can approach it. But whatever makes sense to you, as long as when you're done your geometry is accurate, that would be perfectly okay. So what I'm going to do here is I'm going to offset 10 millimeters. 10 millimeters is the thickness of this part in the top. I'll offset that down as well, and I'm going to offset this over as well. Then I'll just drag this down. I'm going to worry about exactly how far to drag it down later on. Also drag this down. So what I'm doing is just building that L-shaped portion here. Do a fillet with a radius of 0 by holding down. Actually, there is a fillet on that. I think it's 3. A fillet with a radius of 3. Might as well put it in there now. So it's going to look like that. Now I'm also going to take this line and bring it down so it comes to here. Now this line right there, that's going to be trimmed back to this, and that's going to be trimmed back to that. So now you've got, and then these lines right there also have to extend down because the hole goes through both the top plate and the axle support. So that's what that's going to look like on this side. And there's also a fillet with a radius of 3 on this as well. Goes in here like that. So that part fits right in. That's what we have for this. Now we just have to go down and figure out where everything else goes. When I look at this, I realize that it's 48 millimeters from the underside of this axle support down to the center of the hole. So we're talking here, right here. Let me bring that back over where you can see it. Alright, so the distance from the bottom of this down to the center of that hole is given as 48. Over here, it'd be from the bottom of that surface down to here. So I just offset a line down 48 so I could see where that hole was. Now I'm going to bring it through, and then I want to see, well, how big is that hole? When I look at the sides of that hole, I'm just going to take half of it and offset in either direction to indicate where that hole is. I've also got 2 millimeters thicker down here, so that's 10 up here, but right now it goes, right now it's 10 on here, but the raised boss is going to increase that to 12. So if you look at the other sheet, the one that shows all the dimensions, there's your 48 from the bottom down to the center of the hole. We don't really need to know the radius of this, but we do need to know the size of the hole, and if you take a look, it indicates the size of the hole is 22. We'll go back to AutoCAD. So in AutoCAD, I've got this line, and again, the whole purpose of this line is I'm just going to extend it to make it a little more obvious. Offset 11 up and 11 down, that's where the hole is going to be for this. Now, if I also offset the size of the raised boss, and that's also something that's, the raised boss is given as a radius of 19. So from the center, I'm going to go down 19, but I'm also going to go up 19 in order to get the little lines representing the raised boss, which is going to look like this over here. So I need that point right there, and I need that point right there. 19 from the center up is going to give me that. 19 from the center down is going to give me that. Go back to AutoCAD, offset 19. We'll bring that up, bring that down. And obviously I've got to keep track of what I'm doing here. And I can keep track of what I'm doing. And I have another 2 millimeters out here. So I'm going to have to clean this up now. Offset 2. So I'm going to have to clean this up over here. That's going to come all the way down to here. I'll do a little trimming in a minute. Trim down through here. Trim out through here. Here's my hole. Now I'm also going to trim that out and this out. That's where it extends out to the raised boss. I might as well trim that back. Now I'm going to put a fillet with a radius of 3 between here and here. And it might tell me I can't do it. Yeah, it says the fillet is too large. The problem is there is possible to put a fillet with a radius of 3 in there, but Autocad doesn't want to do it. So in order to make this fillet work, what I have to do is extend that line so it's longer than 3. Now when I put the radius of 3 in, looks like that. What that means is I've got to just extend this line to there, then trim this out like that and trim this out like that. That's what the raised boss is going to look like on this side. And then down here, it's also going to have a radius. But up here, this has got another radius of 3. That radius of 3 is going to look like that. Go back and look at the line. No, it doesn't. I'm sorry. That's a machine surface. That was a mistake. I don't need a radius here. I do need one up here, but that's it. You're not going to make that mistake because you're going to follow my instructions on that probably. So I don't actually need anything on here. This is now going to extend all the way down through to the bottom. So it looks like that. Then we'll trim this out, and there's your side piece, and there's going to be that because the axle is going to fit in here. And then the bottom of this is going to have this coming down to here. That comes down to here, which is the bottom of the raised portion of the axle. It's going to come down here. We'll do a little trimming and clean this up. Oop. Do not want to clean it up quite that much. Clean that up. Go over and clean this up. Now I have a hole that goes down through. I don't need that center line. Do a little trimming. Looks like that. And then the bottom of this also needs a fillet with a radius of 3 right there. Okay. So that now gives me the axle support on this side. Now I can simply mirror everything over to the other side to complete this, and that would probably be a good idea if I just got rid of a few things here. So when I do the mirroring, everything I mirror is what I actually need. I'm going to put a window around all this stuff. Go to the center line, come straight down. And then I might have to do, and I do, I might have to add that line in there because it actually dropped down from here. So I'm going to extend that down to here. So now I've got the piece on both sides. And then those two lines have to extend down as well. The reason they didn't go over with the mirror is because I used a window instead of a crossing window. But you can see it's pretty quick to go ahead and do the mirroring. Now you can also have to put center lines in here, and you have to do all the things you've always done on drawings when you do your layers. But this again is an indication of how to deal with the geometry. Now what's going to go right in here is the axle. On this one I'm just going to draw the axle off to one side. And I'm going to draw the axle off to one side and then turn it into a block so that you can just set it in place and then use it to trim to, and it will not consist of a group of lines. Again, you could have made all these things blocks as well, but I think it makes more sense to make a block out of just the things that go on the outside. However you want to do it though, as long as when you're done your geometry is correct. So we'll have, I'll do a center line, and that center line is going to be the length of the axle. And I don't remember how big that is. So, okay, the axle is 80, 20 on each end, 40, 22, and 16. So those are the dimensions we need. So I'm going to draw a center line that goes down to exactly 80. And then I'm going to offset 11 up and 11 down, and then I'm going to offset it 8 up and 8 down. And that's going to give me the size of the diameters. then I'm going to go ahead and do the step. When I get that done, do all the trimming, and then put a chamfer at the end. The chamfer is 2 millimeters by 45 degrees. This should have a 2x in front of the 2 space x space 45. At least I would have put it there to indicate that it's the same on both ends. These are old drawings, and at one time it was simply assumed if you called out a chamfer on a shaft on one end, it meant, of course, you'd do it on the other end as well. But here's a case where the 2 doesn't mean 2 places, and that's why there's a space in between the 2 and the x. It means 2 millimeters by 45 degrees. Go back to AutoCAD. We'll draw a line. Again, I'm just doing this off to one side just to make the block. I could actually go into the block editor if I wanted to, but there's also possible to do a block without going into the block editor, and so for this particular exercise, that's what I'm going to do. Offset 11 gives me the thick part up and down. Offset 8 gives me the smaller part up and down. Now if I come up here and I draw a line that goes from here to here, that's the small part. Now if I move over from here, I go over 20, and then I go from there straight up. Then I'll do a little trimming. I can get rid of this. Now, in fact, this is symmetrical in both directions as well, so I could have drawn a little line here just to do the line of symmetry. I don't need the line, by the way. I'm just doing that so you can see what I'm doing. So now I can take this, mirror it over to here, like that. Now let's trim that up. So we'll trim this up, and we'll trim that, and we'll trim this. This line right here is going to go all the way to the other side. We don't need that anymore, so I'm going to get rid of it. And I don't really need that anymore either, because what I'm going to do is to mirror this material. There's my center. Mirror it over here like that. Now I get to do a trimming again. That actually, I'm going to get rid of that. And instead I'll do a fillet with the shift key held down, and that's going to give me a square corner. And I want that square corner, and I want this square corner, like that. And now all I have to do is put the chamfer in here. That is no longer necessary, so now I've got my axle. The chamfer I'm going to put in with the chamfer command. Chamfer command. The distances are going to be 2 millimeters in both directions. I pick this, I pick that, enter, enter, enter. Now when you have a chamfer that's a sharp edge because you put an angle on it, so you're also going to have a line that comes through here like this. Now I'm doing everything on layer 0 right now, just the way, you know, that first assignment you did where you had everything on layer 0 and had to move it to the different layers that were appropriate. That's what you're going to have to do here as well. Instead of going to the block editor, I'm going to use just the block command. It opens up the original block command. I'm going to call this the axle. And the base point on this, I'm going to pick a point. This one, the base point I think that makes the most sense is actually going to be midway between, I'll show you in a bit why, midway between here and here. And then I'm going to select my objects, which are going to be right here. When I'm done, I'm going to say convert with the result to a block. Now I have one entity here. It's right in the center. So now what I'm going to do is to move this one entity. I'm going to move it from the base point. And the base point is going to be its insertion point. I'm going to move it so that it lines up with that midpoint right there. And, well, I wanted to go midway between. So I'm just going to drop it in place here like that. Now I'm going to move this to the center. Now I probably should have kept that center line in there. So what I'm going to do right now, I'm going to draw a line that goes midway between this point and this point, which now gives me my center line back. And then I can move this axle so that the midpoint of that lines right. I'm going to move this so the midpoint of this lines right up with that. Now I'll get rid of that center line for now. So that's how the axle is going to sit in there, and having it in there now makes it a little easier to draw the bushing. The bushing itself, look over here. and I have to go. So I'm going to put a pause in here, and I'll be back, and I'll do it later on. And I'm back. Due to the magic of video, I just went with my wife and watched a movie and came home. So we're doing the bushing now. So we'll go back and take a look at what the bushing is. The bushing is this thing right here. So you can see it's 19 millimeters long. 12 millimeters is the part that actually gets inserted into that hole. 22 millimeters, so it's going to line right up. And then 34 is the diameter of that. So we'll do the same thing. We'll put a center line down. We'll offset it half of 34 and half of 22 in both directions. And then the 12 is automatically there because we have that B12. And then we just need to have it come in 7 millimeters from that surface. So we've already got that line. I'm going to extend this one down to here because that's where it's going to go. Now we're going to do, I'm going to do a center line. It comes through here. So the 22 is actually already here. We don't need to do that. Then half of 34 is 17. So that comes up to that part and down here to do that. Oop. Down here to do that part. Alright, so we'll trim this out. It comes back to there. Trim that out. Comes back to here. That line actually is supposed to be extended even further down. So we'll get rid of the center line. We'll put an actual center line in later on. Well, I say we will. You will when you do yours. So if I grab that line, I'll drag that all the way down here. That's what that's supposed to look like. Now the offset distance from here, I've forgotten already. Oh, 7 millimeters away. I'll just offset that 7. We'll do the same thing down here. Now Philip, hold the shift key down, be a radius of a radius of 0, so it'll be a nice sharp corner. Now we can extend that line up to here, and this line down to there. And then extend this, draw a little line there because that is a block. We can't extend that, so we're going to have to draw a little line that comes from here straight out to there, from here straight out to there. And that's what that's supposed to look like. And then we'll just do a mirror to get it on the other side. We'll take all of these things right there. And we'll mirror them around the midpoint of any of these. And then over here we just have to take and drag this line all the way down to here using the grip. And that is everything except the wheel. So the wheel is the most interesting thing here. I'm going to drag this down through just so you can see what I'm doing. This is going to be my center line, the line of symmetry. And so what I'll do on this, and here's another case where we really need a line going through here as well. These are construction lines, by the way, but I'm never going to use them again, which is why I'm not putting them on a construction layer. I'm just going to delete them. So we go over and look at some of the, let's actually make this one a little bit smaller, and we'll put it off to one side just so we can have all the numbers right here and you can see what I'm doing. Actually, I say that as though I'm doing this for you. So I can see what I'm doing is the primary reason for doing it. Let me make that a little smaller. Bring that over here. Alright, so now you take a look at the overall height of this is 100. So if I offset 50, and I take that up 50, take that down 50, that's going to give me the limits of the wheel. The width of this is 38, so if I go 19 in each direction, that's the wheel on that side, that's the wheel on this side. And now I'm going to use the fillet command again just to clean up that corner, so because it'll do it automatically and do a trim back when I do it as well. And we'll do the same thing down here. Shift, And the thing about the trim command, the thing about the fillet command, when you do it with a radius of 0, it allows you to both trim and extend depending on what you need to do. Now I'm not quite done with that, but I will just trim that out, and this, not that, this out, because that has to sit in there all by itself. This is nice. At one time in Autocad you could not trim to a block, but you can now. So I'm leaving that center line in just to be able to finish up the wheel. So if we take a look, the line where the wheel is sitting on the axle is the same size, so we're going to leave that. 38 is the same width for that hub right there. So now all we have to do is the part in the middle with the I-beam looking thing, and that's 10. So we'll come back over here and offset that 5. And again, we'll do a trim. Here's a case where picking the cutting edge makes sense. Personally, I think that should be the default still, because now it allows us to come through here and just clean that right up to this and do another fillet like that. Alright, so now we've got this part, so we can do this. We can draw a line that goes from here down 3. Draw a line. You can see that the beginning of this goes down 3, and then it's tapered, so it goes down 5. So what we're going to do is draw a line. I'm going to hover over this, go straight down, type in a 3. Then I'm going to hover over this, go straight down, type in a 5. That gives me that angle that I want, and it stops in the right place. And I can also then go in, hold the shift key down, put a fillet between these two things right there. And at the bottom we have a hub, and the hub is 38. Half of 38 is 19. So we can't offset this because it is a block. So instead I'm going to just start here, go up 19, and then come I started, of course, in the absolute wrong place. Alright, so what I want to do is I really want to offset this. So that's what I'm going to do, is offset that 19. So that comes up 19, comes up to there, that comes down 19, comes to here. So there's where the hub is going to be. Again, the fillet command is really helpful because it allows you to clean that. It allows you to clean up corners really easily. Now I'm going to have to go back and draw this line down. Offset this up 19 again. So what I want here is a fillet, a sharp corner that goes right here. And then this, I want that to come all the way down till it touches here. And then I'm going to do a little trimming and get rid of this. Why is it going all the way up? I'm not certain. But do I not have... So I should be able to trim this right up to there, which I can do. And then we'll trim this one out as well. And actually, let's just get rid of that and get rid of this. So now what I can do is mirror these lines right there, right around here, bring it over like that. Now I no longer need this, and get rid of it. That's exactly what that should look like. It's got a couple of, let's go back over and I'll show you what I mean by that. See, that line's going to come down in the back as you can see it. So it's got a couple of fillets here, and those fillets have a radius of 3. So we'll do a fillet with a radius of 3. Clean that up. Clean that up. I could have done this before doing the mirror, and I should have. Well, I shouldn't have. If I'd thought of it, I would have. That doesn't matter when you do it. So now, if you notice, everything we need is here. Now we can do another mirror and take all these lines right there. We don't need that side line, just those. Go from the midpoint of this, across, enter. And that is the entire section done. Now the only thing left to do is a hatch pattern, but you're not going to do a hatch pattern on this until you set up a layout. So the question is, what kind of layout can you set up? I'm not going to go through everything here. You know how to put center lines in. You can see there's a center line on the bolts, also a center line down here. What I'm going to do, though, before placing the hatch is go set up a layout so I know what plot scale I can use. Because hatches can be annotative just like text and dimensions can be annotative. So I'll right click, page setter manager. It looks to me like B size is going to work on this, so we'll just quickly set up something B size, monochrome, so everything comes out black and white. I'm going to do a DWG to PDF because that's how you're going to submit it. Well, you're going to submit that with something else. This is a metric drawing. However, we are going to use ANSI size paper, ANSI full bleed B, and automatically scales 1 to 25.4. We say, all right, okay, now we'll bring a title block in. You know how to do that. I don't need to go through that process. This is going to fit inside your title block, so make sure it goes all the way out to here. Then we want to try at 1 to 1 and see what happens. I'll come over here. I'll try a 1 to 1 scale. Looks like this, and all I really want is that, which means I can now crop the view. I'll leave that top piece in because I ever need it, but I don't want it as part of my drawing. So I can crop the view by just making my viewport smaller. And then you can project off of this to do the drawing and everything else. So you'll start by coming over here and putting a circle that has a diameter of 100, and there's your wheel, and then you just build the rest of it the way that you would build anything. Now, we know we can go 1 to 1. We're going to lock the viewport, and now we can put those hatch patterns in. So the hatch command is going to open up a special ribbon here at the top, and the ribbon it opens up is the hatch ribbon. And if you pick a point, it'll fill it up with a hatch. Right now the hatch is set to something we don't want. We're going to use either ANSI 31, ANSI 32, or ANSI 33 on this. We'll go 33 first, just for the heck of it. So that comes in, we're going to do that, and that's it. That's all one hatch pattern. Now that actually looks pretty good. And by the way, put this on a layer for hatch patterns. It's going to be thin lines. Now, one of these is going to have to be 45, and the other one's going to have to be something other than 45, or at least it's going to have to be the mirror image. So when you put the other one in, you have to come over. Let me try something. I've always been curious if they might have actually made this possible. No. See, the trouble with the hatch pattern, when you mirror it mirrors it twice. So you have to put this in separately. I don't know quite why that is, but you do. So I bring this down here. So what we're going to do is go up in the angle. We're going to change the angle from 0, which is 45, because that's the angle it comes in at, to 90. So now it goes back the other way. Now that hatch pattern is taken care of. And if we don't like the fact that it looks a little bit, we want a little bit smaller scale. Up here we've got the scale. We could set that to 0.8, and I think 0.8 would actually be a little better. Do the same thing with this one for the scale, 0.8. So I think that would look just a little bit better. Now the other dimensions that we're going to put in, this right here, by the way, is going to be phantom lines. You can see that. Obviously, that's going to go in a phantom line layer. Those are going to be thin lines. And then it's steel, so that's ANSI 32, which is right here. So there's this, and this, and this. Now you're going to have to mess around a little bit with the angle. I think on this one I'm going to change that angle so that it goes negative 15 degrees. So it looks like that. Now I go back over here, get another hatch pattern. This one's going to be ANSI 31. Take that and this, but we don't want it at the same angle, so we're going to change the angle back to 0, so it looks like that. And those are a little too close together. Let's go back to 1 on that one. Alright, so that takes care of this, and you notice it has to be the same all the way through here. Now this one has to be a different angle than that, and this has to be a different angle than that. So we'll go back to the hatch. is still ANSI 31, and you can place it first and then change it later on. So I want that to be, I'm going to use a 45 on that, but I'm going to go in the other direction, so it looks like that. Looks good. Go back to hatch. Same hatch pattern. Now we're going to pick the other side. Obviously that has to also be flipped because right now it's going the wrong way. 0, because it comes in automatically at 45, 0 is what's going to give it to us. And then the only thing left to do for a hatch pattern is the one in the middle here. It's still 31, but again, what we don't want, this, I don't know why it's still a problem. If that's off the screen, it doesn't see it, so it won't see it as a closed boundary. So part of that was off the screen. So for this one, I want that to be a different angle than anything else on here. So let's go with 15 degrees. And you see how that comes in now, so it's clearly a different angle on all of those things. And did I change that? Yeah, that somehow turned into steel. It's not supposed to be steel, it's supposed to be, but maybe I'm not sure what happened when I was drawing. I wasn't paying attention, so we'll go back over here and make that steel. Notice I can just pick it and then pick a different hatch pattern and it makes it steel. Okay, now after this you're going to have one other thing I want to make sure you do, and the other thing is you're going to have a detail up here. Put that detail in here, just adjust your viewport so it's only what you need, enough room for your dimensions. And then you're going to put another viewport in. You can do that by going to the Layout tab, picking it, and then coming back over here and say, let's make a rectangular viewport. Or in this case, we could have even better. Let's put a circle on here. I don't think we've seen this yet. I'm going to move that circle. Comes down here a little bit. Now, we can turn any closed entity into a viewport. When you come over here, instead of picking rectangular or clip or lock, what we're going to do is to pick under rectangular and instead pick object. So we grab that object. Now we have a circular viewport. We're going to want to zoom in on just one detail, and the detail is going to be right here. And what we want is for that to be 1 to 2. You make it 1 to 2. I'm sorry, 2 to 1. You make that 2 to 1. See, you thought you were the only ones that made that mistake. So once you've got that where you want it, you're going to lock that viewport as well. The next thing is you can adjust this viewport now by moving it. Say, yeah, I want to bring it over here someplace. I want to bring it up here. Just put it where you want it to go. And you can also make it larger or smaller, depending on how much information you want to get in there. Then you would label it. So that should take care of everything you haven't done before. Yeah, I did a regen just to get those hidden lines to show up. That should take care of everything you haven't done before. The rest of it is just drawing geometry. You know how to do tangencies, etc., etc. Go back and take a look. Oh, I'm sorry. There is one other thing. The one other thing is this. I want you to put tables in here. So let's talk about tables, and that'll be the end of this presentation. And for tables, I'm talking about a table like this one. So you notice it has 3 columns. It has headers, and then has 9 rows. So we're going to go back to Autocad. And we need to create a table style. Table style is the name of the command. It comes up by default. Standard is set. Should be able to add a new one. The OM is what we're going to call it. We should be able to delete standard when we're done, so we'll continue. What this is going to do is allow you to determine how it's set up. So you can have a title on this. The one that I gave you doesn't have a title. It's just a straight bill of materials, so all it has is a header date, header information. So we can go here. And what we need to do, oops, I just canceled out. Let me do another new one. BOM, bill of materials, what it's called. It's a style. I'm going to start with standard because that's all we have. So now what we can do here is determine the size and the type of font used for each of the cells. So right now the text style is based on standard because that's all there is. So you will have to create a new text style. So you can call it whatever you want. Let's call it with Arial on this one. That's the mechanical part. Let's go to the Roman S. Once you've created that, go over and set the text style font to Roman S. Don't make it annotative in this case. Tables are always placed in paper space, are always placed full size, so the text should also come in full size. So we'll set that as our standard. Close this. Now we can come over here, and under data we can pick Roman S. Text height for data, well, 3 millimeters is what we want. So let's go with 3 millimeters, not 4.5. And everything else is the same. Now we come back up here. The header material, in this case, I'm going to make that 3 as well. And then the title material, if we had a title on here, we'd want to make it 6. In both cases, though, it has to be Roman S. So let's make sure I've done that. Header, yeah, Roman S. Or Arial. You can use Arial if you prefer. Now, all this does is set up the format. It doesn't actually design a particular table. But when we're done, we'll go to the table command. Table command allows us to pick a style. Well, the only style we have is BOM and standard, which you don't want to use. So there are 3 columns in this, and we'll adjust the column widths later on. And then the data rows, well, there are 9, but actually what we want, so you notice over here it has a title, has a header material, has data rows. All we have is a header material, so we're going to get rid of the title. If we're going to get rid of the title, we can come over here. That first row we're going to turn into the header material. The second row we're going to make data. So now we want 3 columns and 9 data rows. I can't remember if once I establish that as data, I think we're going to have to put in 10 in order to have it come out. So let's find out what we get. So we put it in place. It's a lot bigger than it needs to be. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's your header material. Yeah, we don't need nearly that many. What we need to do is to go back and change that to 9. We can do that after the fact. What I want to do here now, though, is this. I want to adjust this table. And I want to adjust the table so it's smaller. And that means taking each of the rows and making them a little smaller. Let's start that over again. I will say the tables are not as easy to work with as I think they should be. I'm going to start over. I'm going to put the table out on the side just so I can see where it goes. I need 9 data rows. And if I'm going to use the data, the row height, 3 lines, let's go with 1.5 lines. If it will let me do that. Will it let me do that? Oh, it has to be an even number? It does have to be an even number. Now I'm going to put this over here. I don't actually want this first one. That is a header material row no matter what. So I'm going to right click, delete that row. Do I have enough? So I got the header 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I have a header and then information and room for 9 other pieces of information. Let's see what happens when I type in anything here. If I do item number, uppercase, yeah, I just wanted to make sure. I want to actually change the height of the rows to 1 line. So let me start this process over, go back to table. Yeah, so row height 1, that's going to be plenty. I want it to be a little bit smaller. The row width we're going to adjust after we put it in just to make sure it looks right. And then, okay, we'll put this right here. Yeah, that's a lot better. So that's going to fit in there a lot better. And the only thing I now have to do is to right click and then delete that row. All right, now, so if we come over here and double click, item number, and over here was description, and then quantity. Now obviously we don't need as much room for the item number and the quantity, so if we take the row and then we move this in here, That's going to make that smaller. And all we need is just enough room. In fact, because it's just numbers in here, I'm just going to reduce that to item number so we can make it even smaller. Once you get this all done, get back to here. Once you get this all done, now you just type the information directly in. That's going to be more like this, and this is going to be more like that. Now this one changes the size of the whole thing. And I get that to the point where I just want to make sure it fits on my sheet. And when I first brought it in, obviously it didn't. So go with one line. Now we'll move that over here. That should fit right up inside your title block. And now when you fill this out, you just put the number 1, tab over, put whatever your description is. And if you want that to be centered, you can do that. You can come up here and you can adjust the formatting on each one of those. Under justification, top right, so let's go to middle center, then it would look like that. So that would work, and these are all middle center automatically, but that one would work better for putting that number in. Then put the description in here, just double click and type it in. Quantity, we could even make that a little bit smaller as well, especially if we change quantity to something like that. So it's pretty clear what we're doing. And then you can take the whole table. We have to be careful. You can pick this and end up with just one cell. You pick, you get the whole table. So now I'm going to make just that one smaller so it looks like that. There we go. So that should give you plenty of room to put everything in. Just double click, double click. You know, you need 4 of something, you put in the 4, go down through and do it. Everything else you know how to do.